So we have a classic example of inverse functions here. So if I'm given a temperature in Celsius, I can easily find the degrees in Fahrenheit. So if I put in 0 for C, I get 32 degrees Fahrenheit. If I put in 10 degrees for Celsius, I get 50 degrees for Fahrenheit, and so on. But what if I had the reverse? What if they told me the Fahrenheit and I wanted to find the Celsius? Well, you could use your algebra every time to find it, or you could just solve for C. So just if you solve for C, you get F minus 32 equals 9/5 times C. And then if you multiply both sides by 5/9, F minus 32 will equal C. And so C equals 5/9 times F minus 32 is your inverse function. And so now you can, given F, find C and just kind of go backwards. And so I've graphed it here. For the original equation, I've got C on the x-axis and F on the y-axis. And then if I were to graph this one, I would put F on the x-axis and C on the y-axis, and I would plot these points. And all the x's and y's would end up switching places. So instead of having 0, 32, I'd have 32, 0. Instead of having 10, 50, I'd have 50, 10. So 50, 10. They just reverse order. The x and the y switch. Instead of having negative 17.8 roughly, comma 0, I have 0, negative 17.8. So I have this lovely line, and they meet somewhere down there. And there you have it. And you see that these lines are symmetric over the line y equals x. Inverse functions will always be symmetric over that line y equals x, and they'll meet somewhere on that line. So if you wanted to set these two equations equal, you could figure out when the Fahrenheit degrees equals the Celsius degrees. So there you have that. And a lot of times when you do it kind of in general, my instructions are to find an inverse, just do a switch and solve, where you switch the x and the y and solve for y. So, but in this case it doesn't make sense to switch the C and the F because, you know, Celsius means Celsius and Fahrenheit means Fahrenheit. The reason they have you do it for other ones is because the axes change. So like this is normally, in the beginning this was the Celsius axis and this was the Fahrenheit, and now this is the Fahrenheit and that's the Celsius. So that's why that happens. Yeah. So we're going to do it again with a normal function. I'm just going to use this guy, switch the x and the y. So remember, this fancy f of x is basically just a fancy way of saying y. And y equals x cubed, so if I switch the x and the y, I'll have x equals y cubed. Solve for y by taking the cube root of both sides. And so if you want to reintroduce the fancy notation, the inverse function is the cube root of x. So if I were to graph the cube root of x, when I plug in 1 for x, I get 1. When I plug in 8 for x, I get 2. When I plug in 0, I get 0. When I plug in negative 1, I get negative 1. When I plug in negative 8, I get negative 2. And so it ends up being this guy here, nice and symmetric over the line y equals x. All the ordered pairs from the original graph were reversed, and that's how that works.